HCF. Dear students, we are going to discuss HCF in this video. I hope you have already watched my video of prime factorization, and it must have refreshed your memory about the factors of a number, the multiples of a number, and the process of prime factorization. Now let us see what is HCF and how to find it. So children, the full form of HCF is highest common factor. It is known by another name, that is GCD, and the full form of GCD is greatest common divisor. It has another name, that is GCF, and the full form is greatest common factor. So as you can see, there is a word which is present in all the three full forms, and that word is the word common. So here we have to find out a factor which is common in the given numbers, in the factors of the given numbers, and that greatest number which is common in the factors of the given numbers will be called the highest common factor, or the greatest common divisor, or the greatest common factor of the given numbers. Let us discuss this with the help of few examples. Let us find out the highest common factor of 12 and 27. So we have already done the factorization of these numbers. So let us see which are the factors of the number 12. The factors of 12 are 1, 2, 3, 4, 6, 12. Now let us find out the factors of number 27. The factors of 27 are 1, 3, 9, 27. So now we have to find out any number which is a factor common amongst the factor of 12 and 27 both. So as we can see that 1 is a factor which is present in the factors of 12 and 27 both, and actually 1 is the factor of every number. This you all know. Now is there any other number which is common in these factors of 12 and 27? Yes, and that number is number 3. So as you can see, there are two numbers which are common amongst the factors of 12 and the factors of 27. and these are 1 and 3. So we can write the common factors of 12 and 27 are 1 and 3. And out of these two factors, we can see the greater number is 3. 3 is greater than 1. And since we know that we have to find the highest common factor, so when we have to find the highest common factor, we will take the greater number or the highest number. So here we can say that 3 is highest of these common factors. So this 3, which is highest of the common factors, this is the HCF of 12 and 27. Therefore 3 is the HCF of 12 and 27. So this is how we find out the common factor, the highest common factor amongst the factors of the given numbers. So there are two methods to find out HCF. Let us discuss the first method, and that is prime factorization method. To understand this, we need to take some examples. Let us take three numbers: 120, 140 and 200. So these are more than two numbers. Let us see how can we find out their HCF. So following the prime factorization method, we need to find out the prime factors of these numbers separately. If we take the factors of 120, so the first prime number we can take here to divide 120 is 2, because 120 is an even number. It is divisible by 2. So the smallest prime number here is 2. So we get the quotient 60 over here. 2 6 are 12 and 2 zeros are 0. Now again 60 is an even number. So we have to take 2 again. 2 3s are 6, 2 zeros are 0. Again it is an even number. So we can take 2, 2 1s are 2 and 2 5s are 10. Now 15 is not an even number. So we cannot take 2. The next prime number after 2 is 3. And 15 is divisible by 3. So we can take 3 here. So 3 5s are 15. Now 5 doesn't come in the table of 3. So another prime number that we can take here is 5 itself, and 5 ones are 5. So what are the factors of 120? It is 2 into 2 into 2 into 3 into 5. These are the factors of 120. Now let us move back to 140 and find out its factors. Again 140 is an even number. So we shall take 2. 2 sevens are 14, 2 zeros are 0. So 70 comes out to be the quotient here, and it is an even number. So again we shall take 2 as the divisor here. 2 threes are 6, 2 fives are 10. So here the quotient 35 is not an even number. It is an odd number. The next prime number after 2 is 3. But 35 does not come in the table of 3. So let us take the next prime number, and that is 5. And 35, as we all know, is divisible by 5. 5 sevens are 35. So 7 again is a prime number. So it comes only in the table of 1 and itself. So we shall take 7 here. 7 ones are 7. So now we got the factors of 140. And these factors are 2 into 2 into 5 into 7. So these are the factors of 140. The next number, we move back to 200 to find its factors. 200 is an even number. It will come in the table of 2. 2 ones are 2, 2 zeros are 0, 2 zeros are 0. Again 100 is an even number. Let us take 2. 2 fives are 10, 2 zeros are 0. 50 is an even number. Let us take 2 again. 2 twos are 4, 2 fives are 10. 25 is not an even number. So what we have to do? We have to take an odd number, odd prime number. The next prime number after 2 is 3, but 25 is not divisible by 3. We have to move to the next prime number, and that is 5. And 25 is divisible by 5. 5 fives are 25. Again we shall take 5. 5 ones are 5. Now let us write the factors of 200. And they are 2 into 2 into 2 into 5 into 5. So now we have the factors of all the three numbers, 120, 140 and 200. Now what we have to do to find the HCF? We have to find the factors which are common amongst the factors of all the three numbers. So let us find out how many factors are there which are common. Let us see. We can see 2 is common 2 times amongst the factors of all the three numbers. Then another number that is common in the factors of all the three numbers is number 5. So now we have the common factors of these three numbers. Let us write them. Common factors are 2 into 2 into 5. And now we can multiply these factors to find out the HCF. So we know 2 2s are 4 and 4 5s are 20. So 20 is the HCF of 120, 140 and 200. I hope you all have understood how HCF can be found with the help of prime factorization method. The second method is division method. HCF by division method. Let us take an example here also. First of all, we shall take two numbers, number 20 and number 36. So there are certain steps which we have to follow over here. The first step is that we have to divide the greater number by the smaller number. So greater is 36, it will be the dividend, and smaller is 20, it will be the divisor. So when we divide this, we see that we take the quotient 1 here and 20 ones are 20. The remainder comes out to be 16 here. We have to continue this method till the remainder comes out to be 0. Now the remainder is not 0. Right now it is 16. Now this is a bit different from our normal division. Here the dividend and divisors keep on changing. So let us see how. Now this remainder which we have got, that is 16. Now this will become the divisor. Initially it was 20, the divisor was 20. Now the divisor has changed. Now the divisor is 16, which is the remainder of the previous calculation. Now what will be the dividend? Now the dividend will be the previous divisor, that is 20. Whatever is the previous divisor, that will become the dividend. Now let us divide again. What do we get? 16 ones are 16 and 20 minus 16 is 4. So now 4 will become the divisor, and this 16, which is the previous divisor, it will become the dividend. Now we shall divide 16 by 4. 4 4s are 16. And now finally we find that the remainder is 0. So which is the HCF now? So this final divisor, which is 4 here, number 4, this is the HCF of the given numbers. We call this as the HCF, and we can see the remainder is 0 here. Only when the remainder comes out to be 0, then only the divisor, the last divisor, is considered as the HCF of the given numbers. So HCF of 20 and 36 is number 4. So here we have discussed about finding the HCF of two numbers by division method. Now let us take more than two numbers. Let us take numbers 6, 8 and 12. HCF of more than two numbers. So they can be any numbers. They can be 3 numbers, they can be 4 numbers, they can be 5 numbers. The process will remain the same. So how can we find them? We have taken 3 numbers, 6, 8 and 12. So what we have to do here, we can take any two numbers from amongst the given numbers. So let us take 6 and 8. We could have taken 6 and 12 also, or we could have taken 8 and 12 also. So initially we are taking 6 and 8. Any two numbers we could have taken. So what we have to do, just like in the previous question, we have to divide the greater number by the smaller number. The greater number becomes the dividend and that number is 8. The smaller number becomes the divisor and that number is 6. So let us divide. 6 ones are 6 and that gives the remainder 2. So this means the remainder is not 0. We have to continue dividing. So as I told you earlier, now 2 is the new divisor. And what will be the dividend? The previous divisor, that is 6. So 2 3s are 6 and this brings us to remainder 0. So which is the HCF of 6 and 8? That is number 2, which is the last divisor. But we had 3 numbers, not just 2 numbers. This is the HCF. Let us write here. Now we have to find the HCF of the 3 numbers. So the process is that we have to take the HCF of these 2 numbers and now we shall divide this number and the third number, and that third number is 12. So 2 and 12. 2 is the HCF of the previous 2 numbers and 12 is the third number. Two is the HCF. So we will use these now as the new numbers. 2 and 12. So greater number is 12, we will make it the dividend, and smaller number is 2, we will make it the divisor. So it is very simple. 2 6 are 12 and in the very first step we get the remainder 0. So this means 2 is the HCF of 2 and 12 because there is remainder 0 now. So the final HCF is number 2. We can say hence the HCF of 6, 8 and 12 is 2. So 2 is the HCF of 6, 8 and 12. This is how we find out the HCF of more than 2 numbers. You can verify this by the prime factorization method as well. One very important point which I want to tell you is that suppose we have two numbers like 6 and 36. So as you can see that 6 is a factor of 36. So when such numbers are there and we have to find the HCF, always remember then this number will be the HCF of both of them. If the smaller number is the HCF of the greater number, then the smaller number itself is the HCF of both the numbers. So here 6 is the HCF of 6 and 36. Now if I ask you the HCF of two prime numbers, HCF of two prime numbers. So let us see. Let us take the prime numbers 3 and 5. So what are the factors of 3? Factors of 3 are 1 and 3, and factors of 5 are 1 and 5. So can you see a common factor amongst the two? Yes, it is number 1. So yes students, number 1 is the common factor, and that is the HCF of these two prime numbers 3 and 5. So whenever we have to find out the HCF of two prime numbers, it will always come out to be 1. So here HCF of prime numbers 3 and 5 is 1. You can take any two prime numbers, the HCF will come out to be 1 only.